In this video, we are looking at mixtures and the types of mixtures. So first of all, what's a mixture? A mixture is composed of two or more substances that are not chemically combined, meaning each substance retains its original property in the mixture. So mixtures can be classified into two groups: homogeneous and heterogeneous. So homogeneous mixtures have the same composition throughout, while heterogeneous mixtures have non-uniform composition. So what's a homogeneous mixture? So as I said before, homogeneous mixture have the same composition throughout. So what makes a homogeneous mixture unique is that the different components are not chemically combined, but they cannot be separated. Physically on standing. So you cannot just separate homogeneous like that. So what examples of homogeneous mixtures do we have? First of all, we have air. So air is the perfect example of homogeneous mixture. So air is composed of many gases such as oxygen, nitrogen, argon, and etc. So each substance in air retains its original property, so and can act on its own. For example, oxygen, the air in oxygen is used for combustion, and also the carbon dioxide is used by plants for making carbohydrates or for photosynthesis. Although they cannot be separated on standing, homogeneous mixtures can be separated by physical method. So this method can be sophisticated. So for example, crude oil is also another example of homogeneous mixture, and it can only be separated by fractional distillation. And this occurs because the different compounds in crude oil have different boiling points. So we use the boiling point property in order to separate them. So solution is a typical example of a homogeneous mixture. So solutions are composed of a solid dissolved in a solvent. So let's define what concentration means. This is just a basic definition. We will look at it in more detail in our next videos. So distillation is the amount of solid dissolved in a known volume of solution. So what examples of solutions do we have? First of all, we have solid versus solid. So in chemistry we refer to this as alloys. So for example, we have steel, which is made of carbon and iron. We have solid versus liquid. An example for this would be seawater, because seawater contains a lot of salt in it, and salts occur in nature as solid. So for example, the salt copper sulfate plus water. And we also have liquid versus liquid, and that is ethanol or alcohol plus water, which gives us wine. So this is a mixture as well. And lastly, we have gas and liquid mixture, that is fizzy carbonated drinks, the ones we drink, cola and Fanta and all of those. So fizzy drinks or carbonated drinks. So what's a resultant volume? What do we mean by resultant volume? So resultant volume, for example, when you mix water with alcohol, the final volume is less than the sum of the individual. This is because of the close packing of alcohol and water. So this will make the final volume be less than the sum of less than the individuals. So lastly, we have heterogeneous mixture. As I said, heterogeneous mixture has a non-uniform composition, unlike a homogeneous mixture. And a heterogeneous mixture can separate into two separate layers on standing. So for example, we have oil and water. This oil and water mixture is said to be immiscible in chemistry because they cannot mix very well. Since oil is less heavier or less denser than water, it's going to float on top of water. So to draw a diagram or visual representation of this, let me see, I have a container here. So there's a clear phase, so it has two phases between oil and water. So the less dense nature of oil will give it the opportunity to sit on top of water. So that's it for today's video. Thank you for watching my video. So if you like my video, please subscribe to me, so as it will motivate me to upload more videos like this. Thank you.